thank you for tuning in. Welcome to a new episode of the Passion for Technology podcast by EBV Electronic.
Welcome to the Passion for Technology podcast. Digital drive technology has been in the public consciousness for at least as long as a British domestic appliance manufacturer has been vaunting its digital motor in TV commercials. But what exactly does digital drive technology refer to? And what advantages does digital motor control offer? We're talking about this today with three experts from EBV Electronic. Uroš Mali is Director Smart Sensing and Connectivity. Hi, Uroš.
Hi.
Milan Ivkovic is Director Analog and Power. Hi.
Hello.
And Ulrich Schmidt leads the high-end processing segment. Hi, Uli.
Hello.
So, Uroš, what exactly is digital motor control?
So, digital motor control refers to the use of digital technology, to control the operation of an electric motor. It can be done using digital controller, taking all the inputs from the, speed, torque, currents, positions, and then adjust the power stage, the output of the motor in order to achieve the desired performance, either position or torque or speed. And, all these digital motor controllers offer several advantages over traditional analog control methods. For example, digital control system can be more precise, can be more reliable, much easier to program, and of course, easier to maintain. And also, very important to mention here, it's allowed much more complex control algorithms to be implemented, which can enable the motor to perform more advanced tasks.
Milan, is there anything you would like to add to that, or is that exactly how you would describe digital motor control?
Yeah, I agree with all I've mentioned, and I would really emphasize that with the current signal processing capabilities that we have, that on the top of digital motor control, we are also able now to add protection, safety, diagnostics, monitoring, and communication, which is crucial for today's systems.
All three of you lead different technology segments. What's the connection and relevance to digital motor control? Uli?
Well, I consider it a multidisciplinary area where basically we have the processing side, we have the communication side, and also everything that is power stage related to, in fact, drive the motor. So from my segment point of view, where I'm heading the high-end processing segment, which comprises all these products that basically are around an MPU, it could be FPGA, it could be system on chips, including all software or new software initiatives like AI. This is basically one of those parts where I see quite important for motor control. And of course, there are different flavors and a wide range from using microcontrollers up to FPGAs that basically can bring all the different components that are required for motor control. And I think, let me hand on to Uroš, who can better point out from the MCU and connectivity side.
On my segment side, talking about smart sensing connectivity, these are where we see microcontrollers really gaining, the performance. So nowadays, you can just use simple MCU to control sophisticated motors. And on top of that, talking about sensing, all the current sensing, position sensing, speed sensing, and at the end of the day, connectivity. This is where we see, big shift. Most of the devices now being part of the, let's say, IoT, let's call it IoT or industrial IoT.
From analog and power point of view, whatever is processed in digital domain will finally end up as a PWM signal that is applied to the motor windings. And so the power electronics, power switches that are driving the motor are here the key from the point of power capability and efficiency of the energy that we are transforming to the motor itself. On the top of that, we have to sense currents and voltages, and we have to process these analog signals and convert it to digital in accurate, precise way, and to have a satisfactory bandwidth for the fast control algorithms. What is interesting also is today's technology that is leading to integration of analog processing into digital ICs and also integration of diagnostics into power switches.
Now, digital drive technology is not necessarily new. Direct current servo motors have been around since the early 1980s. What's different now, Milan? What has changed that it warrants its own series about this particular field?
So what is different today? We can start from the two different approaches. One is for sure what we already mentioned is much more processing power that we can have today. Then we are able to implement more complex algorithms. And not just that is feasible from the point of that, okay, it can be implemented, but this is now affordable. So it can really reach people that are developing different kind of motors, which is now, there is like, let's say, economic background because it's affordable to implement. On the other hand, we have developments into power semiconductor technologies, and putting it all together, there is a wide variety of different applications and control algorithms that can be implemented that are taking maximum of the motor that is spinning. So here, the key for me would be energy efficiency again for given applications, and with the processing power also implementing different kinds of like monitoring or maybe even predictive maintenance on the edge on the motor itself.
Milan has mentioned the edge now. Uroš, you coming from the smart sensing and connectivity part there, and that perspective, what's your take on this?
Yeah, definitely. We also see a bit of shift from the cloud connectivity. In the past, it was everything about the cloud, all the data going to the cloud. But then we really have a lot of data transferred for the data's sake. And as I mentioned, the semiconductors, so especially microcontrollers and microprocessors, really gain the performance. So this is where we can use the edge processing to do a lot of processing in the edge, low power. So it's not talking about really sophisticated computer machines. It's just small microcontrolling doing a lot, and just small amount of data is actually needed to transfer to the cloud for the monitoring, for diagnostics, or for controlling. So this is where we see a big shift, especially because of gaining on the performance on the silicon.
Uli, why and how is this all relevant to a semiconductor distributor?
Well, we as EBV, we can basically pick and choose the right components from all our suppliers that perfectly match with the customer's needs. And some of our suppliers basically just offer the processing part of a motor control solution, while others have the right components for the power stage and connectivity. So basically, we can guide and consult customers and basically be an advisor for the latest technologies to be used in such a motor control use case.
Uroš, what are the most important advantages of digital motor control for you?
Maybe improved precision and accuracies, let's say, on top of the list. Then increased efficiency, especially now with all this, energy deficit on the market. Then, of course, enhanced diagnostics and monitoring, increased system flexibility, and at the end of the day, enhanced safety. So just to expand a bit each of these, so when talking about improved position accuracy, using the PWM, so pulse width modulation, to control the power supply to the motor, it allows much more precise control speed and torque. So we are not only talking about position speed, we are also now talking about torque. And these are, different applications which can get benefit of controlling the torque. Talking about increased efficiency, moving from the DC motor, so direct current motor, to the brushless DCs and PSM-SS, we can definitely increase the efficiency. And this is where also the driving part takes a bit of the share, because especially with higher switching frequencies using new technologies, we can decrease the size of the control system on one hand side, and also we can improve the efficiency. As already mentioned, connectivity is becoming part of the motor control, and this is where we see enhanced diagnostics, not only on the sensor side, but also getting the data to where you need it in the control centers. So even just some dislocated, let's say, pumps, nowadays you can get all the data into the control system. Talking about the system flexibility, nowadays the motor control, especially on the algorithm side, can be easily programmed and configured. So we're not only talking about on-off motor pump rotating, but we can also influence speed. And this way we can also influence, the efficiency, as I already mentioned before. And definitely what I mentioned before, enhanced safety. Digital motor control system can include safety features, such as overcurrent protections, emergency stop capabilities, maybe controlling the torque, what I already mentioned. At the end of the day, functional safety is also becoming more and more into this kind of application. So even, let's say, low-end motor controls, we can get some hardware which includes some functional safety. So this is where enhanced safety is definitely part of it.
That's very broad, actually much broader than I expected. Uli, isn't digital drive technology sufficiently covered by the motor manufacturers themselves? I mean, what can EBV offer that motor manufacturers can't?
As there is still in the technology that is evolving in basically all areas, we are still a good partner for our customers that focus on motors and motor control. There's new technologies arising when it comes to condition monitoring, anomaly detection, or even the predictive maintenance that probably finds its way from expensive motors or systems into smaller and cheaper products to help identify when there is a failure about to happen. So there is still technology that we get informed by our suppliers ahead, that we can convey this message to our customer base for all these motor control applications.
And which customers is your offer focused on, Uroš?
So, traditionally, motor control was in the domain of customers making motors, mechanical parts. But nowadays, this is more like a building block of multiple systems we see on the market. Just a simple e-scooter, just look back last few years, we see really ramping up of, let's say, electric scooters. This is mainly because technology on one hand side becoming affordable. Not only from the feasibility perspective, it was possible to make something small and efficient, able to take the big guy on the small scooter in the hill. And this way we can address wider customer base. So not only the original motor manufacturer, but also, let's say, e-scooter. Even medical is more and more involving, these ventilators, or let's say on the consumer market. We also see a lot of, let's say, drones. Last few years, we see flooding on the simple drones, which are very affordable and very stable when it comes to the, let's say, control point of view. So definitely much wider customer base than just, let's say, mechanical motor controller customers.
You know what? I would like to expand on that. Regarding digital drive systems, which developments in semiconductor technology do you find particularly interesting or exciting even?
So maybe if I just take it from my segment perspective, so definitely increase integration. So advances in the semiconductor technology have made it possible to integrate multiple functions into the single chips. So which has led to the development of more compact and cost-effective digital drive systems. Like I already mentioned, all the drones in the past, I remember 20 years when I still able to do some modeling, flying planes. It was not that affordable. But nowadays you can have nice drones for affordable money. And on the other hand side, enhanced control and communication, and then also using these time-sensitive networks. Ethernet, CAN-bus also improve the control and coordination of digital drive systems. So this has enabled the development of more sophisticated control algorithms and has made it possible to remotely monitor and control the performance of the systems. So this is on my segment side. So maybe on the Milan side, there are another.
Yeah, sure. When I think about motors, I have to think about power for sure and the heat that is generated to run the motors. And in last years, we definitely see development of new semiconductor technologies, so-called wide bandgap, so silicon carbide and gallium nitride, which are very promising in this area because this enables really low losses, and then it means high energy density per motor drive. So definitely this is something that is bringing new light to the scene. And of course, we have a major IGBT technologies developing further, but I would say wide bandgap is something that is really new, and it is to be something that is driving this area in the future. On the top of that, we have new developments of packaging, because this is also important. All of this heat that is generated into semiconductors to be conducted outside of the motor drive. This is one of the key differentiators in the last years. And final thing is, from the point of development, how much of material you have in your motor drive when you're developing inverter. So for sure, for developers, they tend to have as simple as possible system. Even we have complex algorithms and a lot of functionalities. So integration is the key, definitely. And integration of analog stuff, analog circuitry into digital is lowering bill of material for our customers. And also we see a trend of integrating diagnostic features of like small digital portion into power switches or power modules on the drive side. So I don't know, Uli, from your side, maybe.
You just mentioned the level of integration, and I see the same on the processing side. DSPs made their way due to their dedicated instruction set for all the motor control algorithms. I see that moving into the microcontroller space, where we by now have dedicated processing elements to basically do this kind of DSP functionality, along with a perfect set of peripherals like high precision timers that are required for motor control. and as well the increasing memory we can find in microcontrollers or attached to microprocessors. That being actually added by complete solutions you can find in FPGA to incorporate functional safety, connectivity, the motor algorithms itself, all fine-tuned and really can be adopted to the different sensors and also to basically be prepared for the future to add additional functionality. That's, I think, other new additions to the digital motor control also from our silicon side.
Among the many fields that you mentioned, I can very much relate to Uroš, the drone segment or the developments in drones. I have a full garage of drones, it seems, so my wife won't permit me to buy any more, so now I have to do it in secret. But looking at, you mentioned drones, you mentioned scooters. Which markets or applications do you consider to be the driving forces of digital motor control?
So let's say the three main pillars are industrial automation, transportation, and renewable energy. Of course, there are some smaller segments like medical and consumer, but I would focus on these three ones. So this is where most of the time we see requests coming in.
Maybe to add more specifically, when we are talking about transportation, definitely passenger cars and public transportation working on electrical drives is something that is really driving the whole motor control ecosystem, let's say, because when we take a passenger car, we have really limited space. So there is a need for the new materials, as I mentioned, for wide bandgap, for the high power and high-end cars. Then there is a need for sophisticated algorithms. Then there is a need for battery storage. So this is really one of the markets that is driving everything further. And of course, what today we see the trend on energy efficiency. We see the trend of using renewable energy. So these lot of applications like home appliances and so on, we need more efficient motors. And we need more and more motors, for example, for heat pumps, for using, let's say, earth energy around us for heating and cooling. So in all these applications, motors are key. And the more systems are built, this is driving the whole area of motor control further.
Wow, we've really covered a lot of ground. So thank you for that. All the trends, all the relevance of digital drive systems in the 21st century. I think that this was highly interesting. And I also think that your passion for technology comes across. And as you know, our podcast series is named accordingly. What we usually do as a closing question in our podcast series is that I ask you about your passion for technology. And our frequent listeners will remember that Uli, Milan, I've had shows with both of you on. So today, I would very much like to start with you, Uroš, and sort out and understand where your individual passion for technology comes from. And then I would ask Uli, you, and Milan, you, for additional perspectives of the sources of your passion for technology. But let's start with you, Uroš. What are the origins of your passion for technology?
So I believe that my passion for technology is coming from my childhood. I remember those days you could just not get into shop and buy each and every toy you can imagine. And also, from the advertisement or marketing perspective, you could just not see a lot because there was only one media for communication. It was TV. And due to the lack of, let's say, interesting toys to play with, I started to build my own. So from the simple shapes, and this is how I, let's say, become more like a handyman. And then I remember when I was in the 8th grade, so it was in the age of, let's say, 13, 14, because at that time we were still reading magazines. And that was a schematic, how to build a light show. And this was just before the primary school ended, and I already owned my own light show. And I remember I was a king, owning it. And of course, each and every party we were having this light show, and I was really getting a lot of attention.
That's awesome. That's really interesting. Uli, what about you? What's an additional perspective on the origins of your passion for technology?
Right. Since we actually talk about digital drive technology, I think I have a digital heritage for all my professional life, working with digital logic or with microcontrollers, microprocessors, writing software. And for me, it's really the drive for technology, all these amazing stuff you can by now do with software, with the things you can do and improve by adopting artificial intelligence. These are all areas that still keep me fascinating over, I think, more than 30 years of my professional life in the semiconductor industry.
And Milan, what about you?
Yeah, so since I already was speaking about this in previous series, so yes, definitely it is coming from my drive for solving problems. But then in order to solve the problems, you need to use some tools, right? And these tools are at the end a consequence or a product of some technology. So this is how you learn to appreciate available technologies and then to try to make yourself also one of the guys that are part of creating new technologies and delivering something to others which will make their life easier or at least make more fun out of their lives.
And that has stuck with you. That's the root of your passion. Well, thank you for all the insights that you've shared with us today. And as always, you can find more info in our show notes. Please feel free to subscribe to our podcast, Passion for Technology, on either Spotify, Apple Podcasts, or any of the other popular podcasting platforms. Uroš, Milan, and Ulrich, thank you for joining us today.
Thank you, Mustafa.
Thank you.
Thank you.